We're going to talk now about creating a physics simulation using cloth and wind. So the obvious sort of example of that would be like a flag in the wind. So to start off with, we're going to create a really quick and dirty flag scene. And rather than delete my default cube here, I'm going to turn it into a floor. So I'm going to scale it first in Z and then in every axis except Z. So S, Shift Z, and then just kind of scale it up here. And that'll work. I'm going to create a cylinder, scale that in not Z, Shift Z, and then scale it in Z, just kind of make myself a nice tall flagpole. It really doesn't matter all that much where it ends up. Just kind of set things right just for the sake of feeling good about it. Okay, so there's our flagpole. Now I'm going to create a flag. So Shift A, and we'll use a plane for this. Rotate it in Y by 90 degrees, Z. We'll kind of line this up with our flagpole. And I will, GY, that will just kind of extend it out like that. Okay, so there's our flag. Really basic. Let's name our objects here, just because it's a good practice. This scene's not going to get complicated enough to really get lost in the weeds here, but flagpole, it's a good practice. So you might be wondering, first of all, why I didn't use a plane for the floor, and we'll discuss that in just a second. But first of all, what we're going to do is we're going to select our flag here, and we're going to add a cloth sim. So go to your Physics tab, and click on Cloth, and right away we now have gravity going. So if we hit play, you can see the thing kind of pulls a Gandalf here and just starts fleeing in, or falling into the depths of Khazad-dûm. So there are a couple of things at work here that might not necessarily be immediately obvious. First of all, by default, Blender scenes automatically have gravity turned on, and that setting is found here under the scene settings. You can see there's this little checkbox that says gravity, and it has a negative value in the Z-axis. In other words, it tends to pull things downward in Z at negative 9.8 meters per second squared, which is roughly the value of gravity on Earth. So you can turn that off. You know, we could zero that out, and if we hit play here, then nothing happens. The flag doesn't fall because there's no forces pulling it anywhere. Or, you know, we could say, all right, gravity, you are in a y-axis, and then that's what happens. So that's just kind of good to know that that's there in the first place. We're not going to change that in this scene, but I don't know of another good time to bring it up, so I'm bringing it up now and just kind of letting you know that that's there if you want to change it, or turn it off, or, you know, what have you. Okay, so we've added a cloth sim to our flag. We've added our scene already has gravity in it. Next thing, obviously the flag falls through the floor. That's sort of a problem. So let's make the floor a collision object. This won't be useful in the long term, but it will be instructive. So click collision here, and you can see that it has soft body and cloth settings, so that it will be affected. It will affect soft body and cloth. So now if we hit play, you can see that this thing just kind of tromps down and just sticks. Now, one of the things I want to point out, I don't know if this will actually work or not, but let's move the floor out of the way here for just a second, and let's put a new floor in that's made of just a plane. So in other words, it has no thickness in the Z-axis. and let's make that a collision object. And this may or may not stop the flag. Let's see. Oh, it did. Okay. But I wanted to point out one of the reasons that I give the floor thickness is that Blender and other 3D software, when they're calculating for collisions, they only do it a certain number of times per second. And if you have a fast-moving object, there's always the chance that it might make it through your collision object in between collision calculations. That can happen a lot with a plane. It can either start penetrating before, before the calculation is actually made and the computer realizes something should be colliding, or else it might make it all the way through and just have no effect at all. So I like to give my floor a little bit of thickness to sort of help mitigate that problem. And in this instance it didn't turn out to be a problem, but either way it's generally a good practice. Alright, so we've got our cloth sim, and you can see that it remains rigid when it hits the ground. That's because this cloth actually is incapable of bending anywhere. A cloth sim can only bend at an edge, or in other words, a pair of vertices. And this only has vertices on the corners, so it's incapable of bending. So let's select all and let's subdivide this thing a few times. I'm going to say let's subdivide it 60 times. That's kind of nice. Alright, and now if we hit play, we'll get a totally different behavior when this thing hits the ground. You can see it kind of crumples up there and melts like the Wicked Witch of the West. Alright, so now we're going to work on making this thing actually act like a flag. So we're going to pin parts of the cloth sim to the flagpole. And in order to do that, we're going to create a vertex group. So tab into edit mode on your flag, go to your object data properties here and create a vertex group. We'll call this pinning. And I'm just going to select a couple of vertices that I think, maybe 4 up here and 4 down here. I think those are probably likely locations that a flag would end up pinned. So I click assign to assign those vertices to my vertex group. Tab back out of edit mode and let's go into our cloth sim, and if we scroll all the way down to the bottom under shape, you can see that there's a pin group selection area, so we'll select pinning. Now if we hit play, you can see that our flag actually kind of stands by, or it hangs from those pinned areas. It's still penetrating our pole here, so let's go back and turn our pole into a collision object. Hit play again. You can see that that's now behaving a little more realistically there. I'm also going to select my flag and hit shade smooth. That'll just make it look a little better as it deforms. That's kind of nice. Also, just because I want to, I'm going to turn this flag a nice Fujifilm canister green because that's my favorite color. There we go. And that's starting to look pretty nice. I think probably self-collisions will help that cloth object also to behave a little more realistically. So let's turn on self-collisions, and we might need to turn this back off depending on how heavily it has to calculate. That can really take a lot of computer power to calculate those self-collisions, but I'm actually not too unhappy with that, so that's okay. Alright. Last but not least, we want our flag to blow in the wind, so we're just going to create a quick force field. We'll call it wind, move it up here and aim it at our flag. You can see by default its strength is set to 1. And that does pretty much nothing. Matter of fact, just for speed's sake here, I'm going to turn self-collisions back off while we experiment with this. That does pretty much nothing for us. But if we select our wind and change its strength up way high, let's go up like 750 because I've found that wind needs a lot of power. We hit play. it's still doing nothing for us. Let's make sure I'm not missing in an axis or something. Okay, well that is starting to have an effect, but not nearly as much effect as I would have thought. So let's turn that up and let's put it to 7,500. See what happens. There we go. Now we're starting to get our wind really billowing through. And honestly, I've never had to turn the wind up that high, so I don't know quite what's going on there, but that is working. So I guess the takeaway there is that if your flag isn't blowing, keep turning the wind power up until you get something more satisfactory. So that's just a quick tutorial. Again, these are just pretty basic. There's an awful lot you can do with wind, an awful lot you can do, of course, with cloth in order to get these things looking better and exercising more control. But I just kind of want to familiarize you with the basics, and there you have it. So I hope that's helpful, and I hope you have a great day.